Our next speaker is Peter Lewis. He received his bachelor's degree in physics from Oxford University and his PhD in philosophy from the University of California in Irvine. His recent interests center on philosophy of physics, in particular the foundations of quantum mechanics. He was an assistant and associate professor of philosophy at the University of Miami from 2001 to July 2017, where he joined us here at Dartmouth. He is the author of Quantum Ontology, a guide to the metaphysics of quantum mechanics from Oxford University Press 2016, and numerous other journal articles. So Peter, please.
Okay, thanks for the invitation. So, like Janan, I'm going to take my jumping off point, the article in Ion Magazine, The Blind Spot, right? And like Janan, I find a lot to agree with in the article. And at the end, I feel like there's something I disagree with, and I'm not quite sure what it is. I'm going to try and say what that is today, and maybe I'll succeed, and maybe I won't, and maybe the differences aren't as big as I think they are.
The blind spot.
Because no one can see it. Right? Okay, so let me just start with a little bit of recap of what Frank, Gleiser, and Thompson say in The Blind Spot. And all this I agree with wholeheartedly. They identify a certain kind of presumptuousness in the attitudes of some scientists, and especially philosophers who take science as their inspiration, right? That is, there are scientists, and especially philosophers, who take a certain scientific worldview as describing all there is. Right? And they describe this presumptuousness in terms of overlooking the blind spot, that which science cannot see. And that sounds exactly right, that recognizing the blind spot can caution us against various kinds of overreach in science and in philosophy. Right? Where I might disagree, we shall see, is in how they characterize the blind spot. They characterize it in terms of scientific materialism, which they define as scientific objectivism plus physicalism, where scientific objectivism is something like science tells us about the mind-independent world, and physicalism is the position that physical reality is all there is. Right? They say, by forgetting that these perspectives are a philosophical bias, not a mere data point, scientific materialists ignore the ways that immediate experience and the world can never be separated. Right? Inspired by these perspectives, we propose an alternative vision that seeks to move beyond the blind spot. Our experience and what we call reality are inextricable. Okay, so I think I may take issue with some of these. So at the end of my allotted time, right? So part of their motivation they take from Husserl, who Evan mentioned, right? They say Husserl, the German thinker who founded the philosophical movement of phenomenology, argued that lived experience is the source of science. It's absurd in principle to think that science can step outside it. The life world of human experience is the grounding soil of science. And the existential and spiritual crisis of modern scientific culture, what we are calling the blind spot, comes from forgetting its primacy. Right? So in response, I cracked open this book, which I hadn't looked at since grad school a long, long time ago. Right? So now I'm going to say some stuff about Husserl, which is kind of dangerous in present company, but here goes. Right? So one thing to note, all right, so the title of this book, The Crisis of the European Sciences, it sounds like, Husserl's saying there's something wrong with how we're doing science, right? Yeah, it's not exactly right. I mean, the sciences in that title are the German word Wissenschaften, which is like academic enterprises in general, not the natural sciences, right? And elsewhere, the end of this volume, he describes his project as identifying a crisis of European humanity, not sciences, right? So the crisis is not in the natural sciences as such, but in the way they've been incorporated into philosophy or into culture more generally, right? So what's the nature of the crisis in humanity that Husserl wants to identify, right? So here's the section heading: the positivistic reduction of the idea of science to factual science. This is bad. This positivistic reduction. The crisis of science is the loss of its meaning for life. The crisis concerns not the scientific character of the sciences, but rather what they, or what science in general, had meant and could mean for human existence. What does science have to say about reason and unreason, or about us men as subjects of this freedom? The mere science of bodies clearly has nothing to say. It abstracts from everything subjective. So the nature of the crisis that Husserl is pointing out is something like that. Science, like this, science abstracts from meaning and value. So it says nothing about meaning and value. Right? If the extent of assertability or knowledge is taken to coincide with the extent of science, as the positivists maintain, then all human meaning and value falls away. That's the crisis he's worrying about. And he's worrying about this as a Jew in Germany in the 1930s. I mean, the meaning and value falling away is a real crisis. Right? Okay. What is it that science misses? Right? It has to do with the life world, as Evan mentioned, right? So science is, again, this is quoting Husserl again, science is a human spiritual accomplishment which presupposes as its point of departure, both historically and for each new student, the intuitive surrounding world of life, pre-given as existing for all in common. Right? The visible measuring scales, scale markings, etc., in the science lab are used as actually existing things, not as illusions. Thus, that which actually exists in the life world as something valid is a premise into doing science, right? So the life world is something like the intersubjective world of people and everyday objects, imbued with human meaning and values. Right? Science depends on the life world, right? Scientists live in the life world. Scientific lab equipment are life world objects, right? So it's absurd to deny the life world on scientific grounds, right? That's a central point of Husserl's argument, right? And note, as Evan pointed out in a little while ago, the problem here, the blind spot, isn't just the denial of experience, right? It's the denial of the life world, measuring devices, scientists, values, all that life world stuff, right? Okay. But what is science about on Husserl's characterization? He says this: the knowledge of the objective scientific world is grounded in the self-evidence of the life world. The latter is pre-given to the scientific worker or the working community as ground. Yet as they build upon this, what is built is something new, something different. So science presupposes the life world, and as such, it's absurd for science to reject the life world. But it isn't about the life world. Physics isn't about lived experience or about lab equipment as part of the scientist's life world, right? In fact, that's what makes the positivist denial of the life world possible, right? Physics isn't about this stuff. I only believe in the stuff that physics is about, right? It makes it possible. Okay. So, as a quick illustration, right? Think about recent black hole science, right, which has been in the news a lot lately. Right? So you might start with a mathematical model. You've got solutions to some differential equations. You've got solutions to Einstein's field equations. Right? And you notice that some solutions contain singularities, infinities. Right? What do you do about that? Well, suppose those are physically possible. Right? What would it be like if there was a singularity in the middle of a galaxy? Right? So you build a physical model on the basis of the mathematical model, right? Then you go about trying to detect such things, right? So in the recent Event Horizon project, right? So suppose we've got a bunch of telescopes all over the world, right? What if we could hook up all these telescopes together to collect data that could give us direct evidence of a black hole? Right? You collect a whole bunch of data, right? There's Katie Bowman with all the data. Right? And as a result of all this data, you produce the image that's been in the news lately. Right? The black hole image, of course, isn't about experience or life world objects. It's an image for us, right? It's an image deliberately constructed for human consumption, right? But it's not about us. It's not about our experiences. It's about a black hole. Right? It's a visual representation of data, right? A visual representation of data that confirms black hole models, and those models aren't about experience or life world objects either. Right? Although, of course, the project presupposes experiences and life world objects all over the place. Right? Scientists, telescopes, their experiences, all of those are part of the life world. Right? So, sure, the life world can't be coherently denied. Right? And we could, if we wanted to, turn our attention, our scientific attention, to those experiences and those life world objects, right? I mean, this is obviously the case with the telescopes, right? Somebody's business as a scientist was making those telescopes, right? They may have been used as life world objects by the scientists who were constructing the black hole image, but they were modeled as scientific objects by the scientists whose business was making telescopes, right? Similarly, we could turn our attention to human experience and model that, right, scientifically. But in doing so, we would abstract away from their lived meaning, right, in incorporating those things into a scientific model. Right? So what does all this say about the nature of the blind spot? Right? So Frank Gleiser and Thompson say that we got scientific materialism, which is scientific objectivism plus physicalism, right? And they say that close attention to the nature of science challenges both objectivism and physicalism, right? My instant response to that, right, was, yeah, sure, right? The physicalism so characterized is indeed absurd to say that physical reality is all there is, and thereby to deny the existence of experience or consciousness or life world objects, as some philosophers are wont to do, right, does seem like an absurd conclusion, right, when you're presupposing those things in order to do the science that is supposed to undermine them, right? That does seem absurd, right? But where's the challenge to objectivism? Let me turn for the challenge to objectivism to something I know maybe a little bit more about than Husserl, which is quantum mechanics. Right? So nowhere, they say, is the materialistic bias in science more apparent than quantum mechanics. Right? Quantum mechanics is supposed to be about the building blocks of matter. Right? That's what it's supposed to be about. But it notably fails to deliver a description of reality that doesn't also incorporate our experience as observers or measurers, as Chris just pointed out in great detail. Right? Hence, Frank and Gleiser and Thompson say, it reveals the failure of scientific materialism. Right? Quantum mechanics was supposed to be about the mind-independent world. But look how spectacularly it fails to do that. Right? Look at the way in which experience creeps in all over the place. Right? And if you take a look at quantum mechanics as it was or as it is, it sure looks like that's the case. Right? Take a look at the foundations of the subjects, say von Neumann's mathematical foundations of quantum mechanics. Right? You find passages like this. Experience only makes statements of this type. An observer has made a certain subjective observation, and never any like this. A physical quantity has a certain value. Now, quantum mechanics describes the events which occur in the observed portions of the world, so long as they do not interact with the observing portion with the aid of process 2, the Schrodinger dynamics. But as soon as an interaction occurs, that is a measurement, it requires the application of process 1, the collapse postulate. So notice what's going on there. Von Neumann says, quantum mechanics comes in two parts, right? There's the Schrodinger equation, the nice continuous linear dynamics by which the quantum state evolves most of the time. That's the way quantum systems evolve when there's no observation going on. But as soon as someone makes an observation, as soon as a measurement takes place, a whole different dynamical law kicks in, the collapse process by which this spread out quantum state collapses to a precise result. Right? That's right in there in one of the classics of the foundations of quantum mechanics from von Neumann. And then you pick any textbook of quantum mechanics, right? Here's one that I happen to be taught from, right? J.J. Sakurai. Right? Open up any textbook of quantum mechanics and look, somewhere towards the beginning usually, right? You'll find something like this. Before a measurement of observable A is made, the system's assumed to be represented by some linear combination, some spread out state that evolves according to the Schrodinger equation. When the measurement's performed, the system's thrown into one of the eigenstates, right, say A prime of observable A. In other words, you got this spread out state, a measurement occurs, and it becomes this precise state. Thus, a measurement usually changes the state. Right? You find the reference to measurement to implicitly observe as an experience right in there in your quantum mechanics textbook. Right? That's a peculiar place to find yourself, right? If you're seeing science as excluding the subjective, right? Here it is, appearing right in our quantum mechanics textbooks. Right? Okay. What are we supposed to make of that? Right? There's various ways you could go with that. There's the way that Frank and Gleiser and Thompson go with it, that it reveals the blind spot. Right? But there's dissenting voices, and the dissenting voices have always been there in quantum mechanics, right? Here's a famous quote from Erwin Schrodinger in a letter to Bohr. If we have to go on with these damn quantum jumps, then I'm sorry that I ever got involved, right? So Schrodinger was deeply troubled by this division into quantum processes that go on when nobody's looking and quantum processes that go on when you peak. Right, you've got this continuous evolution when nobody's looking and a collapse when you peak, right? And, he formulated his famous cat thought experiment to kind of reveal his dissatisfaction with this division into two processes, right? You all know the story. You've got this little radioactive sample that may or may not decay. You've got a detector that's hooked up to a hammer and a vial of poison. The sample decays, the poison's released, the cat dies. If the sample doesn't decay, the poison's not released, the cat lives. Leave it an hour. Quantum mechanics says the sample is going to be spread out over a decayed state and an undecayed state. Right? Does that mean that the poison is spread out over a released state and an unreleased state? Does that mean that the cat is somehow spread out over a dead state and an alive state? Right? Well, no, because as soon as the measurement occurs, then it's going to collapse to one or the other. But Schrodinger's whole point in making this thought experiment, I think, is to point to a certain absurdity here, right? Which is, well, where exactly does the measurement occur, right? Where does the measurement occur in this process? Right? Is it when the Geiger counter trips or doesn't trip? Is it when the hammer falls, when something macroscopic occurs, right? Is it when you get a living being involved, a conscious being like a cat, right? Or do you have to wait until the human observer opens the box to see if the cat's alive or dead? Right? Schrodinger, the implication seems to be putting measurement in there in your quantum theory is absurd. Right? Here's another well-known dissenting voice against putting the word measurement in quantum mechanics, right? From an article called Against Measurement. Right? John Bell says this: in other contexts, physicists have been able to take words from everyday language and use them as technical terms with no great harm done. Take, for example, the strangeness, charm, and beauty of elementary particle physics. No one is taken in by this baby talk, as Bruno Touchet called it. Would that it was so with measurement, but in fact the word has had such a damaging effect on the discussion that I think it should now be banned altogether in quantum mechanics. Right? Okay. Of course, he didn't really mean that measurement should be banned altogether in quantum mechanics. That's kind of hyperbole, but he does think that the way it's being used in quantum mechanics is damaging. Right? Why is it damaging? Right? Well, for roughly the same reasons that Schrodinger thought it was damaging. And he points to the same kind of absurdity. What exactly qualifies some physical systems to play the role of measurer? Was the wave function of the world waiting to jump for thousands of millions of years until a single-celled living creature appeared? Or did it have to wait a little longer for some better qualified system with a PhD, right? So what both Schrodinger and Bell are pointing towards, of course, is the measurement problem, right? So I want to give a maybe slightly Husserlian spin on the measurement problem. So measurement, ordinarily, is a life-world term, and as a life-world term, it's entirely unsuited to appear in a scientific theory. Right? Why? What makes the word measurement unsuited to appear in a scientific theory? Right? Schrodinger and Bell stress the vagueness of life-world terms. Right? And that's certainly one aspect of a term like measurement, right? And life-world terms in general, they just don't seem to be as well defined as physical terms. But that seems to be almost accidental, right? The deeper issue seems to be that life-world and experiential discourse on the one hand, and scientific modeling on the other hand, have very different functions, right? We could turn measurement into a scientific term. Right? We could abstract from its everyday particularity and incorporate it into a precise model. Right? In fact, that's precisely what's been done in a certain approach to the foundations of quantum mechanics that Bell quotes approvingly at the end of his Against Measurement paper, namely the spontaneous collapse approach of Ghirardi, Rimini, and Weber. Right? So the spontaneous collapse approach has it that, yeah, sure, measurements trigger collapse, but here's why. We have to model measurement in a certain way as a certain kind of amplification into the macroscopic world, and then introduce a certain physical process such that amplification causes collapse, right? So then we got a precise model that incorporates measurement, right? But it does so by abstracting away from measurement as a life-world term. The measurement as it appears in GRW theory is now a very different kettle of fish from measurement as it occurs in everyday discourse. Right? You've incorporated measurement into your scientific theory by turning it into something else, by turning it into the object of a scientific model rather than part of lived experience. Right? The same kinds of worries are gonna go for observation or experience or appeal to macroscopic life world objects, right? Observation and experience also crop up in quantum mechanics a lot, right? And you could have the same suspicions of these croppings up that Schrodinger and Bell do. That this is no place for life-world terms. Why not? They have a very different function from scientific terms. The result is going to be an omelet that's hard to unscramble, in a memorable phrase. Okay. So what's the general problem here? I've been teaching philosophy of time, and I've been having a lot of fun teaching philosophy of time. And in particular, I've just taught this classic article, The Myth of Passage, by P.C. Williams from 1951, where Williams is... well, let me just read the quote. Right? Williams is endorsing a very similar picture of time to the one that Janan was sketching, I think, but Janan laid it out in beautiful detail, and Williams does it in kind of overblown prose, but his overblown prose is kind of nice in some ways. Right? He says, suppose we're comparing the scientific picture of time as this four-dimensional block with time as experienced, right? We say the block's inadequate to the experience. Why do we say that? Comparing the calm conceptual scheme with the turbid event itself, we may be repelled by the former, not because it's not true to the latter, but because it is not the latter. When we see that this kind of diversity is inevitable to every concept and its object, and hence is irrelevant to the validity of any, we demur, because the conceptual scheme is indifferently flat and third-personal, like a map, while the experienced reality is centripetal and perspectival, piled up and palpitating where we are, grey and retiring elsewhere. Right? Okay. So what's he pointing out? Well, he's pointing out, look, time in physics is not lived time, right? Time in physics is a representation, right? It's inevitable that what appears in the physical theory is not lived experience, right? Because it's a representation of lived experience, right? It's not lived experience. Right? That's inevitable. And it doesn't challenge the accuracy or objectivity of our scientific theories of time or of anything else that lived experience doesn't appear in them. Right? Okay. So what should we make of this concerning the blind spot? Right? Well, science gives us abstract, idealized, and partial models, right? In particular, and this, I guess, was one of Husserl's point, it abstracts from human values and meanings, right? And hence it can't capture lived experience or life world objects. Right? So as such, I agree with Frank Gleiser and Thompson that there are some things that are necessarily beyond the reach of science. Right? Scientific reality is not all there is, and denials by some philosophers that scientific reality is all there is do seem absurd in that light. Right? But I think I side with Williams here that this is not a fault in contemporary science that needs to be overcome. Right? The models that science gives us can be perfectly accurate as abstract, idealized, and partial representations of the world. Right? They can be perfectly accurate representations of the world. Any attempt to incorporate lived experience into science itself is bound to fail, I think, since it's necessarily going to abstract away from the lived nature of that experience. Okay, so here's another quote from D.C. Williams that I just want to close on, right? It's a kind of caution that he ends the myth of passage with. This is, the last sentence of the myth of passage, right? Most of the effect of the prophets of passage, right? People who think there's something missing from the scientific view. Most of the effect of the prophets of passage, on the other hand, is to melt back into the primitive magma of confusion and plurality, the best and sharpest instruments which the mind has forged. Some of those who do this have a deliberate preference for the melting pot of mystery as an end in itself. The others hope eventually to cast from it, no doubt, a finer metal and to forge a sharper point. I suggest to them, however, that if a tithe of the genius and industry which they spend on that ill-omened enterprise was spent on the refinement and imaginative use of the instrument that we have, whatever difficulties still attend to it would soon be dissipated. Okay, thank you.
Going to your slide of Schrodinger's cat,
Yeah.
I just want to comment that I think the distinction between live and dead is probably oversold, and the argument doesn't carry so much weight for at least some class of people. But more seriously, when you talked about Schrodinger, I feel that you mischaracterized him a bit. And I don't know that I'm adequate to do this in the way that or to make the point that, I don't know that I'm as adequate as Michelle for making the point. But I wouldn't say that Schrodinger felt along with Bell that the notion of measurement was too vague to be invoked, but rather he saw a contradiction between Bohr's view of, maybe not Bohr, but Bohr, Pauli, Heisenberg. When they introduced observer into physics, Schrodinger felt that to be doing science to begin with I believe he called it objectivize. And so we take the observer out of science. We take the agent, we take this knowing subject out of science. And so when the Copenhageners were reintroducing observers into the story, he felt that there was a contradiction with the notion that they were practicing science to begin with. Or at least that's my reading of him. So it wasn't about vagueness. It was about an inconsistency as he saw it.
Cool. That's awesome. I mean, I don't know that bit of history as well as I should, and that's awesome because, I mean, for Bell it does seem to be about vagueness, right? And you know, as I said, the vagueness almost seems incidental. Yeah, measurement is a vague term, but you know, and we shouldn't have vague terms in our physical theories. We should precify them. But that almost seems orthogonal to the lived world, scientific world question, right? So I like that Schrodinger was more concerned with getting the observer out of there, with that, abstracting away from the subjectivity. Right? That fits better with the way I'm trying to think of it. So yeah, it's very good, very helpful. Thank you.
Just a quick comment. So yeah, I think Bell and Schrodinger were just concerned with what I think Bell later called the speakable and unspeakable in quantum physics, which is the notion that, wait, everything is made of little quantum objects, including the detectors. So when an electron hits a detector, at what point is the electron seeing the detector as a classical object, which is what we use to interpret the existence of the electron? And that, to them, I think, was the big conceptual difficulty, you know, where do you draw the line? And the poor cat there, in a sense, is the inadequacy of the wave function to be taken seriously as an object of reality. That, to me, is the real criticism that Schrodinger was bringing in.
Okay, so you could, right, so you could use Schrodinger's cat, right, as a criticism equally of many worlds type understandings of quantum mechanics, right? Schrodinger would say, I don't like that either. Here's why, right? Right. Whereas there's no measurement vagueness in no ineliminable measurement vagueness in many worlds of quantum mechanics, right? So you know, so there's so many measurement problems, right? There's so many things that people are concerned about, right? One is, you know, vagueness of measurement. One is, look, measuring devices are just made of quantum systems, right? So they can't obey a different fundamental dynamics because they're just made of Schrodinger evolving systems, right? There's another measurement problem, right? What I was trying to suggest is maybe there's a third way of understanding the measurement problem. Maybe Schrodinger had these kind of concerns too, that life world expressions have no place in physical sciences.
Yeah.
That in order to scientize something, you have to abstract away, in some sense, from the particularity of experience.
I think he would be horrified with Everett's many world interpretation. I think he passed away before Everett, I think. I'm not quite sure. But he would probably have hated it. I'm not sure. I don't know. Anyways, that was very useful. Actually, if you have a comment, we do have 2 more minutes. Anybody? Yes, please.
Yeah, so
Here, you need to use the...
Hi, so maybe following up on that theme, at some point in your talk you spoke about the satellites used to image the black hole. And you pointed out that the satellite initially is treated as an objectified object of science for the technician and the people who built the satellite, and then later is used as a part of the life world in order to look at the black hole. And it seems to me that a big part of the mystery that we're talking about is how can a piece of the life world function in these dual ways? How can something go from being first an external scientific object and then miraculously become a piece of the life world?
I don't know. I mean, but you know, people make these things, right? And it involves a lot of scientific modeling, right? That involves abstract models of particular systems, right? Semiconductor technology and who knows what else, right? But you know, once they're made, then we use them and they become part of human discourse, imbued with human values and all that kind of stuff, right? They take on life world values and meanings for us when we use them, right? But that's very different than what I was sort of suggesting. Is, you know, there's two kinds of discourse about telescopes or satellites or cell phones or anything else. There's scientific discourse and there's life world discourse, and they're separate ways of talking using separate vocabularies, and trying to insert the vocabulary of one realm into the other is liable to land you in confusion.
At least I guess it would be fair to say that there's something very special and particular about the satellite that enables us to use it as part of our perceptual apparatus. We couldn't just do it.
Science is doing that all the time, right? It's taking, it's extending our perception in various ways. It's producing technology that then becomes part of our life world. That's certainly an interesting process. Yeah.
Okay, great. Let's thank you.